body surface area. So it's 1.73 cubic meters of body surface.
Is that meters squared or?
Meters squared. So this is your standard way that you would report GFR. But in most cases, they don't take into the last one in account. The only time they ever do this in terms of it, if a person is really obese, and which could be fairly common now, or someone who's the very opposite, who's very, very slender. Other than that, they usually don't take into the account the body surface. Okay. So usually it's on average in a female. So the amount is usually in milliliters, and the unit time is usually in minutes. So in a female, she'll range around 150 milliliters per minute. 115. Oh, sorry. 115 milliliters per minute. Thank you for correcting. Because sometimes my brain and my mouth don't connect correctly. Okay, so here's your amount, 115 milliliters, and there's your unit time. In a male, his is usually a little higher because he has a little bit more body mass. And it's around 125 mLs per minute. But again, you're going to have a range, depending. You can have, say, 105 to 120 for a female. You can have for a male, he could be 120 to 135 and still be okay. All right? We're okay? So make sure that you know the normal values. So this is something you should know. The GFR is important. You're going to spend a lot of time in nursing school on physiology. So really anything greater than 90 mLs per minute is normal. Okay, 60 and below is abnormal in terms of flow. Okay, so how do they measure the GFR? GFR measurement. Okay, there's a number of ways of doing it. One of them is that you can use an endogenous molecule called creatinine. This one is made in the body. You covered it when you covered muscle for ATP reduction. So yeah, the creatine phosphate versus ATP. So it's normal from the muscle breakdown to create creatinine. And so this is found in both the blood and the urine. Okay, this creatinine is filtered, but usually not reabsorbed, and usually not secreted. But because there can be some variations here in the secretion, it can alter the GFR a little bit. And you can look at this. If this is from muscle, if you have someone who has an illness that has broken down a lot of muscle tissue, that could affect the GFR. You see someone who is a football player with lots of muscle mass, that could be it too. But for most of us here that are normal size, normal occupation, things like that, this is usually what they use. If not, they can inject a plant carbohydrate called inulin. Okay, inulin is a plant carbohydrate, and so they inject it, and it's not reabsorbed. It's not secreted. It is filtered, so they can measure the amount of what they put in versus measure the amount of what comes out.
and some sugars, yeah, like the,
Yeah, I think there is a fiber, or I think they add as a fiber, yeah. The only problem with inulin, and then these three. And then the third one, they may use radioactive tracers. Can you imagine that price is pretty expensive for that, radioactive markers? They usually use the first one because it's endogenous, it's normally found in the body already. You're not constantly having to inject the inulin and figure out, keep track of how much you put in, things like that. And so, so that's usually the standard that they use, but not always. Okay, so the equation for GFR is going to be the urine concentration times urine flow divided by the plasma concentration. So in most cases, we're using creatinine, so we're going to look at the urine concentration of creatinine times the amount of urine that's produced per given time divided by the plasma concentration of creatinine through a blood test. And they can also do that with the inulin too. So this is your equation, you need to make sure you know it, okay? So urine usually is collected over a 24-hour period. Here, okay? If 1440 milligrams of creatinine was collected over 24 hours of urine, how much creatinine is produced per minute? So, work that problem. Okay, yeah, good with your calculator. So usually when they do these GFRs, they collect it over a 24-hour period. I mean, not necessarily consistent, you can't be with the person 24 hours, but they usually try to do that. And they usually kind of check. So if you had a patient and you did collect urine over a 24-hour period, and you found out that in that 24-hour period, that urine had 1440 milligrams of creatinine, how much creatinine is there in the urine when you bring it down to a minute? Because the urine concentration is going to tell you your urine concentration. Remember, the GFR is in minutes, usually. mLs per minute, so that's what we're doing, that's where we're going. We'll wait till everyone gets a chance to work on it. Did you set it up as an equation? If you did, then you can put it on the board. Did you set it up as an equation like you do in conversion equation? did everyone else get an answer? Anyone want to put it on the board? As a conversion thing? Okay, how many got 10? 8? 100? 12.5? 0.1? Oh, now we're getting closer now. So what's the answer? The answer is 1. 1 milligram per minute. Okay, so let me give you a problem to work on, so you have a problem just like this. So you have a patient. Patient has 1.25 milligrams per milliliter in the urine. This is creatinine. 1.25 milligrams per milliliter in the urine.
What is this?
1.2.
Okay?
What is it?
The
1.25
urine is producing
milligrams.
60 milliliters of urine per hour. 60 milliliters of urine is produced per hour. They took a blood sample also and found that the plasma concentration of creatinine was 0.01 milligrams. Zero point zero one milligrams. Per minute. I need that per minute in there. So calculate the GFR of this patient. So you have all three things to fit in that equation.